This tutorial is for ellipses, Algebra 2, section V1 through V5. The first thing I would encourage you to do, if you have not already done so, is to check out the flipped math video, 11.2 under Algebra 2 Traditional. It combines ellipses and circles, so you only really need kind of the first half of that, and it'll go through and explain all the different parts that I'm going to walk you through as well. So I would definitely encourage you to do that first, and then if you haven't already, do that and then come back here, or if you have, then we'll just keep rolling. So the first thing you need to know about an ellipse is it's like a circle, but it is longer one way than it is another. So you can either have a horizontal ellipse where it's longer lengthwise than it is tall, or you can have a vertical ellipse where it's taller than it is wide, right? So those are your two types of ellipses, and you'll have to recognize which way they are in order to identify all the different parts. So as you can see, I am terrible at drawing these, but we're going to still use these as an example. So I have two completely labeled, and then I'm going to walk through another two examples with you, labeling them as we go. So our first one, you can see, is a horizontal ellipse. Our center here is at the origin. So the first thing I wrote down to describe this ellipse is that it is a horizontal ellipse. It's wider than it is tall. The second thing I wrote down is the center is at 0, 0. We also call that the origin on the coordinate plane. The vertices, you have vertices and co-vertices for an ellipse. Your vertices are where it stretches out to its widest point, and your co-vertices are where it stretches out on the other side. So if it's horizontal, your vertices will be located like this, and if it's horizontal, they'll be like that, and your co-vertices will be here. If it is a vertical ellipse, you will have vertices that are on top of each other like that, and then co-vertices that are located across from each other. So we have a horizontal ellipse with the center at 0, 0. So now we just need to identify its vertices. So this goes out as far as -6 on this side and as far out as +6 on this side. So my vertices are at -6, 0 and +6, 0. So that's the long way of the ellipse. My co-vertices are how far it stretches up and down. So my co-vertices are located at 0, +4 and 0, -4 here. So now, once you've identified if it's horizontal or vertical, you have two types of axes. You'll have your major axis and your minor axis. So what that means is your major axis is the longer one, and your minor axis is the smaller one. So we're kind of describing the length of the ellipse at its longest point, and then its width, right? So for my major axis, I had 6 this way to the origin and 6 this way. So 6 plus 6 is 12. So the length of my major axis is 12. For my minor axis, I'm looking at this part. I had 4 here and another 4 here. So it's 8. So you should have the same length on this side as you do on this side, and the same length here and here. So that origin cuts those axes in half. So now let's look at one that's completely labeled that is much smaller, and you can see that it is a vertical ellipse, right? So here we've moved our origin, or we moved our center away from the origin. Here it was at 0, 0. Now it's at a different place, right? So my center here is at 0, 1. So I labeled that. It's also a vertical ellipse. My vertices are at 0, 4. Let's see, 1, 2, 3. I think they're supposed to be at 0, 3, sorry. And 0, -1. So I think I just counted too many on that one, sorry. So let's see, 1, 2, 3. Yep, that was supposed to be a 3, sorry. And then at 0, -1. And then co-vertices are at -1, +1, and positive 1, right? My major axis then is here, so it's 1, 2, 3, 4 in length. My minor axis will be across here, so it's 1, 2 in length. Now, let's look at 2 more, and for these, I haven't labeled everything, so I wanted to do it with you. I'm trying to write sideways, so my handwriting's not going to be great. The first thing that we need to identify is if this is a horizontal or a vertical ellipse. So this is a vertical ellipse. And then we're going to look for this center. So this is our center. So it's at 1, 2, 3. So -3. I wish I could write better sideways. And it's not up or down, so it's just at -3, 0. My vertices, remember, are going to be located at the end of the major axis. So first I'll label this one. So 1, 2, 3. So it's at -3. And then 1, 2, 3, 4, 5. So -3, +5. That handwriting, my goodness. And then this one is going to also be located at -3. Let's see where it goes. 1, 2, 3, 4, 5. So -3, -5. All right, my covertices are going to describe the ends of the minor axis. So I have 1, 2, 3, 4, 5, 6. So -6, 0. And then my other covertice or covertex is at the origin, so 0, 0. Boom. All right, now I need to describe the length of my major axis and the length of my minor axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Length of my major axis is 10. And then that also makes sense since we went from 5 to -5, right? And then my minor axis, 1, 2, 3, 4, 5, 6. The length of my minor axis is 6. All right, so that was a vertical one. Let's look then at a horizontal one. All right, so for our horizontal tiny ellipse here, I need to go ahead and let myself know horizontal, can't write sideways. All right, and then our center is at 1, 2, and then down 1, 2, 3. So 2, -3. Right, so 2, -3. My vertices, remember that those are the endpoints for my major axis. So -1, -3. Ooh, that handwriting. All right, and then 1, 2, 3, 4, 5, -3. All right, covertices are the endpoints of my minor axis. So I have 2, -1. And then, let's see, 2, -1, and then 2, 1, 2, 3, 4, 5. So 2, -5. Ooh. All right, my major axis, the length of that is 1, 2, 3, 4, 5, 6. Minor axis, 1, 2, 3, 4. All right, and that's it. So we have labeled all of our main points of these. As you're doing your homework, this will help you with sections V1 and V2. The first ones will ask you maybe like the center and the vertices or covertices, and then V2 will ask you more about like the major axis and the minor axis. It's going to take you into problems that have formulas and everything like that. If you want to go past that, if you want to do those problems, you can, but I'm trying to give you a little bit easier homework this week, so you can absolutely hit your points goal without doing that. So let's move on to our next section, which would be V3. And for this video, I'm just trying to put everything in one longer video for you. So you can pause it, do the work, and then come back when you're ready for V3. So for V3, your task is to find the foci of an ellipse. So it'll give you an equation like this, and then we're meant to find those 2 points that are the foci. So you'll have something that looks like x squared over a number plus y squared over a number equals 1. So the first thing we need to see is if it is horizontal or vertical, right? So how we determine that is if the bigger number is under the x, it's horizontal. If the bigger number is under the y, it's vertical. So I've come up with my own little shorthand here, h and v for that. And that will determine where we're adding or subtracting our numbers. So the first thing you need to do when you see an equation like this is to decide if it's horizontal or vertical. If it's horizontal, you'll be adding or subtracting your c value to the x, which in this case is called h. So if it's horizontal, you're adding and subtracting your c to the h. If it's vertical, you're adding and subtracting your c value to the k. So I'll remind you of that as we're going through those, but that's why the first thing you need to do is determine which is the bigger number, and is it under the x or the y? If it's under the x, it's horizontal. If it's under the y, it's vertical. All right, so now that we have that, we use our special formula that says that to find c squared, we first must find a squared and b squared, and then it's a squared minus b squared. So we determine that we need to remember that a is always greater than b. So you say, what's the difference in these two numbers? Whichever number is the bigger number, that's your a. So 72 is bigger than 63. So I'll write down a squared is 72 and b squared is 63. So my formula just says c squared equals 72 minus 63. And remember, this is kind of a manipulation of the Pythagorean theorem, which is a squared plus b squared equals c squared when you're trying to find the hypotenuse of a triangle. So 72 minus 63 is 9. Since this is squared, I would take the square root of both sides. The square root of 9 is plus or minus 3, but since we're talking in distance, it has to be positive. You couldn't measure something, the length of something in a negative number, right? So it's going to be positive 3. So now that we know the value of c, we're going to add it to our h value, and we're going to subtract it from our h value. So what I need to see is if there's anything else going on in this x squared and y squared. If it's just x squared and y squared, then we know that the origin, the center of your ellipse is going to be at the origin 0, 0. So I take that 0, 0, and since it's horizontal, I'll be adding 3, and then I'll be subtracting 3. So for one of the two vertices, it's going to be 0 plus 3 is 3, and then this 0 doesn't change, so you just copy down your k. For my other, it's negative 3, because 0 minus 3, and then 0. All right, I know that's a lot, so let's walk through a couple more examples to help you. Number 2, we have x squared over 65 plus y squared over 69 equals 1. So the first thing we need to see, which number is bigger? It's 69, and so this is vertical. So I write down my little formula again so I know what to do once I find my c value, right? So since this is vertical, once we have that c, we're going to add it to k, and we're going to subtract it from k. Just like in number 1, there's nothing else with the x or the y, so we know that our center is at 0, 0. Our a squared is our bigger number, so 69. Our b squared, 65. So we just take 69 minus 65, that's 4. The square root is 2. So to 0, 0, we're going to add 2 to our y value, and subtract 2. And I said y, but we call it k in this instance, right? So the 0 stays the same, so if I'm writing two ordered pairs, I can just say 0, comma, and then 0 plus 2 is 2. Then another one, 0, comma, and 0 minus 2 is 2, negative 2. All right, let's do a couple more. Number 3, x squared over 5 plus y squared over 9. Our bigger number is 9, so that's our a. It's under y, so it's vertical. So this is our formula. A squared is 9, b squared is 5. 9 minus 5 to get c squared is 4. Square root is 2. So to my k value, again, there's nothing else with that x and y, so our center is at 0, 0. I'll be taking my c value and adding it and subtracting it. So 0 plus 2, 0 minus 2, or negative 2. All right, number 4. X squared over 7 plus y squared over 11 equals 1. It's vertical because our bigger number is under the y squared. So once we find our c, we're adding and subtracting it to k. There's nothing else with our x and y, so our center for this one is also at 0, 0. Now we just need to solve for c. Bigger number is a, smaller number is b. We subtract them. 11 minus 7 is 4. The square root is 2. So we're adjusting our k by plus 2 and minus 2. So 0, 2, 0, negative 2, which has been a popular answer today. Number 5. X squared over 10 plus y squared over 59 equals 1. All right, so our bigger number is located under y, so this is vertical. Here's my formula. Now I'll need to find my c value by, let's see, this would be a because it's bigger. This would be b because it's smaller. 59 minus 10 is 49. Square root of 49 is 7. So there's nothing else going on there with my x and my y. So my center of my ellipse is at 0, 0. I'll be adding and subtracting 7 from that k value. So 0 plus 7, 0 minus 7. All right, number 6. X squared over 84 plus y squared over 88 equals 1. Bigger numbers under y, so it's going to be vertical. This would be my formula. A squared is 88, b squared is 84. 88 minus 84 is 4. The square root of 4 is 2. So once I see that there's nothing else going on there with the x and the y, I know once again my center is at 0, 0. And so I'm going to be adding 2, my c value, and subtracting 2, and then that will give me my ordered pair for that. There's a couple more examples here because you're not always going to have that nice clean x squared and y squared, and then your center will not always be at the origin. So number 7 is our first example of where it's a little different. So we have x squared, so our h value is going to be 0, and then our y value, remember you take the opposite of that, you have to change the sign. So the center of this one is at 0, negative 8. Okay, we do everything else the same. So 81 was our bigger number, it's vertical, it's also the a, our 81 value. B is 16. 81 minus 16 is 65. So we've got a couple complications in this one. You can't take the square root of 65 and get a nice clean answer like we have for some of our other numbers. So we're going to have to leave this as the square root of 65. But we'll have to add it, sorry that's tiny, and subtract it from our k value. So our two values, our two ordered pairs here are 0, which didn't change, 0, and then negative 8 plus square root of 65, and then 0, negative 8 minus 65. That's all you can do on that one. It looks funky, but that's exactly the correct answer. All right, let's look at number 8. X minus 10 squared over 64 plus y squared over 49. So let's go ahead and identify what our center is. The opposite of minus 10 is plus 10. And then there's nothing with the y, so it's a 0, right? Our bigger number is under the x, so it's horizontal. So this is our formula for that. So our a squared is 64, our b squared is 49. We subtract those and then get our c squared. Now our c is getting added and subtracted from the first number, and there's nothing we can do about that 15. There's no way to clean that up. So we're just going to leave it as 10 plus square root of 15, comma 0, and 10 minus square root of 15, comma 0. All right, number 9. X squared over 64 plus y minus 9 squared. Our center of our ellipse here, there's nothing with that x, so it's 0. And then minus 9 becomes positive 9. our biggest number is under y, so it's vertical. So we'll be adding and subtracting our c value to our y. A squared is 81, b squared is 64. Our c value here then is c squared value is 17. Can't do anything about that, so we'll be adding the square root of 17 and subtracting the square root of 17. And it looks just like that. All right, I'm going to leave you these other two to practice on your own so we can get to the next section for your homework. So, V4 is write equations of ellipses in standard form from graphs. So for this one, they're going to give you some information, they're going to give you a graph and you're going to gather some information from that. And I've labeled a little extra on the first couple just to help you. So if they give you a graph, again, these are just rough sketches. And for this one, our center is at the origin, so 0, 0. Our vertices here, we have 9 and negative 9 on the y-axis. And our co-vertices, that smaller minor axis here, negative 3 and 3. So I went ahead and came to the side and labeled the center is at 0, 0. My a value, remember, is the distance from the center of the ellipse out to the end of the major axis. So this part here, our b value is from the center out to the end of that minor axis. So from 0 to 9 is 9. It's our bigger value, so it's our a. From 0 to 3 is 3, so it's our smaller value, right? It's also a vertical ellipse, so what that means is that our a value, our bigger value, is going to go under the y squared. Now since our center was at 0, 0, we don't have to do anything else to these. We can go ahead and write down our shell. So x squared over a number plus y squared over a number equals 1. Now our bigger number, remember, goes under the y squared, so it's 9 squared, which is 81. Our b squared value then goes under our x squared. So a squared goes under the y squared if it's vertical, and b squared then would go under x squared. Number 2, I have our rough graph here, a rough sketch of this. Our origin once again is at 0. The value of a, this distance, is 10. This distance for b is 6. Since this is a vertical ellipse, I know that my a value is going to go under my y squared. So the center was at 0, 0, so I don't have to add anything to the x or the y. My a value is my bigger one, so 10. My b value is 6. Since the larger one goes under y squared, 10 squared goes under y squared, and 6 squared goes under x squared. All right, number 3. We have an ellipse here. It's almost a circle. When I drew it, it looks a little bit more like a circle because it's just a sketch. But our larger distance here is our 5, and our smaller distance here is our 4. And our center, again, is at 0, 0. Since it's vertical, even though it doesn't look like it much on our little graph, the a squared is going to go under the y squared. So our a distance, our a value is 5, our b is 4. So our center was at 0, 0, so it just stays x squared and y squared. A squared goes under y, b squared goes under x. Remember, it's always equal to 1. You don't have to worry about that one as much. All right, a couple more examples. I think the graphs just get worse and worse as we go. So number 4, we have a vertical ellipse. That's the center is at the origin. At its longest point from the center to the end of the major axis, it's 10. Our b value here, this distance then, is 2. Since it's vertical, our a value goes under the y squared. So once we complete our shell and we write x squared plus y squared equals 1, we just have to decide where the a and the b squared go. So a squared is 100, it goes under y. B squared is 4, and it goes under x. Number 5, we have a really lopsided drawing. Sorry, guys. Our center then is meant to be at 0, -2. It's a horizontal ellipse, so that means that when we find our a squared, that value is going to go under x squared. And then let's see, our a value. So even though it passed through this x-axis at -8, its farthest point was at -9 and then at +9 here from the center. So that value is 9, and then from the center out to the end of the minor axis, that value was 4. Again, it'll be so much easier to see on the computer when you have full graphs in front of you. So now that we know that, this is our first example of something that the center was not the origin, right? So for our x value, it's still 0, so we leave that as x squared. Our y value, though, -2, remember we have to change that and flip-flop it and make it a +2. So x squared plus y plus 2 squared. And then our bigger value goes under our x because it's horizontal. Our smaller value goes under our y. Again, just to save a little time because this video is already pretty long, I'm going to leave you number 6 to practice on your own. All right, and then our last section for this week. V5, write equations of ellipses in standard form using properties. So our first one gave us this information. The center is at 0, 0, the vertex is at 0, 12, and the covertex is at -5, 0. I still love the idea of sketching these first. What the center tells us is that this x squared and y squared, you don't need anything else with that. Once we sketch this, we can see that it's a vertical ellipse, so our a squared value will go under y squared. With the center at 0, 0, this major axis ends at 12 and -12. So the value then of, a is 12. From the center to the end of the minor axis is 5, so our b value is 5. So we'll square our a, and because it's vertical, we'll put it under the y squared, so 144. For our b value, 5 squared, the 25 goes under x squared. All right, number 2, center at 0, 0, so that means x squared and y squared stay the same. I sketch it out with the vertex at 0, 10 and the covertex at -4, 0. Looks like it's vertical, so the a squared value, once we know it, goes under y squared. To determine the a and b, we just measure this value from the center out. So our a is 10 and our b is 4. We square both of those, so 116 are our two values, and our a squared goes under y squared, and our b squared goes under x squared. All right, number 3, vertices at 0, 10, and 0, -10, covertices at -3, 0, and 3, 0. This one's a little different. It didn't give us the center, but once we sketch that, we can see that the center would have to fall halfway between -10 and +10, and here between -3 and +3. So even though they didn't say it, sketching it out tells us that our center is located at 0, 0, which means we keep that x squared and y squared. Use this to find the distance of a and the distance of b. Since it's vertical, the a squared will go under y squared, so 100 and then 9. All right, let me do one more with you and then leave you the last one to practice on your own. So number 4, our center is at 0, 18, a vertex is at -6, 18, and a covertex is at 0, 23. So once again, I started by sketching this out. So the center was at 0, 18. A vertex was at -6, 18. So since that is a vertex, then we know that we can go that same distance and find the other vertex. Covertex at 0, 23. So we can see what this distance is and then turn around and go the same distance to find that other covertex. So that's how I got all of those points on there. Looks like it's a horizontal one, so our a squared will go under x squared. I measured my a value, so my longest point here, 6, b value, 5. I squared those and put them under this, but now you notice that since our center isn't at the origin, it's at 0 on the x-axis, so we don't change that, but on the y-axis it's at +18, so we'll need to put -18 inside here before we square it. I'll leave you the last one to try on your own, and I'll load all of the notes in PDF format to Edmodo. And that's it.